My name is Melanie Harlow, and I'm a product engineer on the Raster team here in development at Redlands. And joining me today is Peter Becker, who is the Imagery product manager, who's also located here in Redlands. We want to welcome you today to the live training seminar. Today's seminar will focus on the methods to manage imagery in ArcGIS 10. Some of these methods are familiar to those of you who have worked with ArcGIS before. First, I'm going to present an introduction to imagery in ArcGIS 10. Then I'm going to focus on two methods for managing imagery in ArcGIS. The first one I'm sure you're all familiar with is using raster datasets, and the next one is our new Mosaic Dataset. I'm also going to introduce you to dynamic mosaicking and on-the-fly processing concepts. And finally, I'll discuss how to share or disseminate your imagery. I'd also like to encourage all of you to submit questions at any time during this presentation. There'll be a few points throughout and at the end where we will stop and answer your questions. So let's get started with an introduction to imagery. So there's no confusion. I just want to make sure that we all understand that the term imagery in ArcGIS is used to describe all forms of raster data in ArcGIS. This can be aerial photographs such as tiled orthophotos like DOQQs or satellite imagery. It includes imagery from any type of sensor such as a multispectral or thermal sensor. It's elevation models or scan maps. It can be thematic raster data such as a land classification or the grid-based output from an analysis or interpolation process. Basically, imagery in ArcGIS refers to any raster or cell-based data. A complete GIS enables all forms of geographic data and information to be integrated and accessible. This information can come from different sources, such as geographic content, from base maps, from knowledge bases often stored as models, or from sensor networks providing real-time data. Often the biggest contribution of this information comes from imagery. For it to be valuable, all of this information needs to be accessible to a range of different users, be they the managers of the data, the users in the field, analysts, or decision makers. A complete GIS, therefore, needs the tools to manage many different forms of data, and good supportive imagery is core to a complete GIS. And I think you'll see that ArcGIS gives this to you. So first I want to outline what I feel are the four main goals for image management. The first one is data storage. It should be straightforward and it should be scalable and efficient. The next, you should be able to create something like a catalog that's both quick and easy to create and also is easy and quick to retrieve the data that is cataloged. Not just the pixel data, but also any of the metadata and any of the other associated information. Managing data isn't always as straightforward as just cataloging what you've received from a vendor, but it can also involve creating the output that your data users need. So aside from just creating a catalog, you should also be able to define the outputs of the data. Basically define how the data will be processed, such as any enhancements, setting band combinations, clipping, and so on to create your image products. And finally, dissemination. Make it accessible. Make it accessible on my desktop, over the web, in my applications, on my handheld device. And I want it all accessible. Because if I'm the user, I want the source data and I want the process data because I want to control what I do with it. At 10, there's two ways that we recommend you manage your imagery. One method is using the raster dataset. This is the storage of individual images. And this isn't new to you if you've already worked with ArcGIS. The other is the Mosaic Dataset. This is new at 10. The Mosaic Dataset is our new model for managing collections of imagery and raster data, both small and extremely large collections. Now I'm going to talk about just managing those single images. Imagery, as you know, can be stored as files that you manage on disk, and these can include formats like TIFF and Mr. SID or GRID. They can also be stored using a database management system within a geodatabase as a raster dataset. Raster datasets can have one or more bands. And the pixel depth for each of these bands can range between 1 to 64 bits. These datasets can be compressed or uncompressed. ArcGIS supports several different compressions, such as LZ77 and JPEG. Compression is often important to understand because it can reduce your storage space requirements and it can impact the pixel values, meaning the pixel values can be lost due to the simplification algorithm used in the compression. Thus, the compressions are often grouped into a lossy or a lossless category. You don't want to use a lossy compression when the pixel data is important, meaning it's for analysis, not just for display. But a lossy compression often reduces the file sizes more than one that is just lossless. So there's pros and cons to each. Whether your data is stored as files on disk or in geodatabase, there's properties associated with the imagery, such as a spatial reference or statistics. These are either managed within the format or externally. For example, your TIFF file can contain a header information where the spatial reference is stored, or there may be an auxiliary file with the spatial reference information. A lot of people are familiar maybe with a world file that might have this. Additionally, metadata, such as information describing the data provider, the date the imagery was collected, and a contact name and address for more information can also be similarly maintained. Often, metadata is stored in a separate file. Pyramids are also considered property of your imagery. They are reduced resolution representations of your image, and they're used to speed up the display of the raster data. Pyramids can be stored internally or externally. For example, with a Mr. SID file, they're stored as part of the file structure. ArcGIS can generate pyramids, and this is recommended when they don't exist. Pyramids also affect your management because they increase the storage requirements by approximately 3 to 10%. Generally, when storing your image data, we don't recommend that you convert your files. However, if you need to optimize the access to the data because the data format is slow to read, we do recommend a tiled TIFF, generally with JPEG compression, but if you need lossless, then we also recommend LZW. ArcGIS has more than 50 tools just for image management. These tools are organized into either the conversion toolbox or the data management toolbox. The conversion toolbox contains tools to convert from one to many of the other formats that we read to the ones that we can write, including TIFF. You can also convert from a vector or point file to a raster. The data management toolbox contains most of the other tools, such as tools to clip or rotate the images or define a projection. One of the new tools that we've added at 10 is the Build Pyramids and Statistics tool. This tool allows you to point to a workspace and build pyramids and statistics on all the imagery files contained within that location, including any subfolders. One of the key management workflows that ArcGIS provides is being able to generate processed imagery without having to generate intermediate products. A raster layer is one example of how easy it is to define processing on the fly. A raster layer is created as soon as you add a raster dataset into any of the applications, such as ArcMap. You can also create one directly in the catalog. A raster layer references a raster dataset. When a raster layer is accessed, any processing defined within it is applied on the fly as the data is accessed. The processing that a raster layer can define includes a stretch type or enhancement, band combination for multiband datasets, and parameters for pan sharpening or orthorectification. At 10, we've added the capability to apply processing functions, which we'll discuss later. And of course, if you need to export the processed imagery to a file format, you can also do that. You don't have to save it as a layer file. So next I'm going to do our first demo. We're going to take a quick look at a raster dataset and its properties, and we're going to create one of those raster layer files to do on-the-fly processing. So here I have my catalog window, and I have an image dataset that has no pyramids or statistics, but I want you to see the properties here. We've got the raster name, where it's stored, how many rows and columns, pixels, how many bands that we have, the format that it's supported, the number, the bit depth. There's a lot of information in here. We also have a report on whether or not there's pyramids and statistics. Now there are options here to build both of these within the dialog, but I don't want to do that. I actually want to run this tool. because if I were to do in that dialog, it would be 2 separate steps, and I would prefer to use the tool that allows me to do it in 1 step. So I'm going to go and do a search for my tool. And open my tool. I'm going to point to that file that we're just looking at. And I'm going to build the pyramids and the statistics at the same time. So what I'm doing now, this is new at 10, it's processing in the background. You can see a little report down here telling me what's happening. I can also go to the reporter window, or the results window. And this tells me what my inputs were in case I've forgotten. It also will tell me what's happening. So right now it's still building the pyramids. I just want to say that we recommend that you build pyramids on really large data sets. This is especially useful for displaying your data. If you find that your data is displaying slowly and it doesn't have pyramids, I would fully recommend building pyramids. And also statistics, you only need to build them on data sets that haven't already been enhanced. So my process is done, and it added it to my display. So next what I want to do is make it a little larger. I want to set up some defaults. So right now we have 6 bands to choose from. I want to actually make it so that my image is a specific band combination, and I prefer a 543. I just think it's pretty. It's very green. I also am going to show you this new window called the image analysis window. Now I can close my table of contents up. I'm going to choose my band. One of the things about this image analysis window is it allows you to change, your renderer, your stretch type. I'm going to change my resampling to bilinear. I'm going to check this off to turn the background off. And so now I've basically changed my rendering properties, which normally I would have to go into the layer properties dialog box to do. The next thing I'm going to do is I'm going to draw a polygon, because not only do I want to render something, but I also don't want to serve up the whole image. So I'm just randomly drawing a polygon here. And I can use this clip tool to clip it to the graphic that I just created. And I turn off my source, and you can see that the raster has been clipped. And we can zoom and pan around. It's still a valid data set. I'm going to go back to my table of contents. I'm going to save this layer file. So now I can use this layer file to make this image, the way it's been clipped, available to anyone, including myself. All right, so we reviewed how to manage and work with single image files. Now we're going to discuss how to manage imagery with the new Mosaic Dataset. Mosaic datasets allow you to quickly catalog small to massive collections of image and raster data. This can include any raster datasets, raster layers, and imagery from various satellites and centers. The Mosaic dataset allows you to define the output of imagery from the Mosaic dataset by defining processing that would be applied on the fly, such as enhancements, color correction, pan sharpening, and more. And you have the ability to define rules for how the imagery will be dynamically mosaiced. There are 2 main ways in which you can access a Mosaic dataset: as a single image, just almost like a regular raster dataset, or as a catalog. A Mosaic dataset is stored within a geodatabase, and there are geoprocessing tools to help you create and modify the Mosaic dataset. And because it's geoprocessing, you can also easily automate your workflows using models and Python scripts. It's a very simple workflow to build a Mosaic dataset. First, you create the Mosaic dataset. This is basically an empty container, and then you populate it with your imagery data, and your Mosaic dataset is ready to go. You can also additionally stop and edit its properties to modify functions and create specific outputs. We're going to walk you through each of these things through different demos throughout this seminar. ArcMap also provides an environment for editing and viewing all of the components of the Mosaic dataset. In ArcMap, you can view each of the layers, such as the footprint and boundary. You can interactively edit the attribute table, and you can use some of the vector editing tools to modify the vector components. When you add a Mosaic dataset to ArcMap, it's added to the table of contents as a special group layer containing at least three layers. The boundary layer is the extent of all the raster datasets defined by their footprints within the Mosaic dataset. This is a polygon feature class that's stored within the geodatabase, and it's shown in this graphic as the pink polygon. The footprint layer defines the outline of each image within the Mosaic dataset, which is shown in this graphic as all the green polygons. Each image in the Mosaic dataset is clipped by its footprint or the boundary, so you can modify the shape of these if necessary. For example, if you add scanned maps to the Mosaic dataset, you can modify the footprint to exclude the map marginalia rather than cropping the actual image files. The footprint layer also contains the attribute table for the Mosaic dataset. Each row in the table represents an image in the Mosaic dataset, and the metadata for each image can be stored within different fields in this table. Therefore, users can query the Mosaic dataset based on the attributes in this table. And finally, the image layer, it displays the imagery. It has layer properties that control the rendering of the Mosaic image similarly to a raster layer. You can modify the display properties such as the stretch, the bands in an RGB band combination, resampling, and a mosaic method. But any of the modifications that you make to the image layer properties don't actually affect the Mosaic dataset, just how it's rendered at the time that you're viewing it. There's also a seam line layer. This will be present if seam lines have been created or added to the Mosaic dataset. Seam lines are another option besides the footprints for controlling how the rasters are mosaiced together. So this moves me into my next demo, where I'm going to show you how to create a Mosaic dataset, add imagery to it, and then modify the attribute table. So I'm going to close a few things here. Insert a new data frame. Can this open? So first I'm going to go to my catalog window. I can create it in the geodatabase that I already have, but we're just going to keep things clean. I'm going to create a new file geodatabase and give it a name. And then right-click on this geodatabase, go to New, and I can create my new Mosaic dataset. I'm going to give my Mosaic dataset a name. Oops. And I can specify a coordinate system. Now in this case, I'm going to use the same coordinate system as my source imagery, but I can choose whatever is appropriate. So once it's done, it's added automatically into my table of contents, and it's just an empty container. We don't have any footprints because we haven't added any images. So I go back to my catalog window, and I can right-click and go to Add Rasters. And I have a number of rasters in a folder location, so I've selected Workspace, and now I'm going to navigate to that location. And the other thing I want to do is build overviews, so I'll just check that on. So you can see as it starts to work, it's locked the Mosaic dataset, so I can't make any edits to it now while it's being edited. Also, I'm going to go back to my results window, which I already have open. I'm going to expand this a little bit so we can read everything that's there. So what's happening is it's loading 32 data sets that it found into my Mosaic dataset. And I just want to make it clear, I'm using terms loading and adding. We aren't physically moving the raster data files or the image files. We are just creating a link to where those source files live. And it also goes through, it builds the boundary, and it builds my overviews. So this got done quickly. My lock is gone on the side here now. And here's my Mosaic Dataset. I'm just going to turn some of these things off and show you we have the boundary, we have the footprints representing each image, and then we have our dynamically mosaic image. And I can zoom and pan around and do whatever it is that I want to do to navigate through this image. One thing I want to show you is the attribute table. It has some specific fields. There's a unique object ID for every image that gets added. The name of the file that I added is located. There's some other fields in here, such as a tag and a group name. But what I want to do is I want to actually add my own field. And I'm going to give it a year. And I'm just going to set my year to 2002 because that's when all my imagery comes from. And I want to do this because maybe someday I'm going to update this, and if I do it from another year, I want to be able to search on the specific year. So my Mosaic Dataset is ready. I can now provide it to another user. I can use it myself, or maybe I can serve it up. So we'll go back to, we have our Q&A. So I'm going to move to Peter now, who is going to answer some of your questions.
Thank you, Melanie. A number of questions coming in, so I'll quickly go through as many of these as I can. Riyadh in Tampa is asking, does imagery include temporal raster data, i.e. over time, so that we can see movement of shade or rainfall, etc.? So yes, we're using imagery in a very generic form to mean really any type of raster, including data from analysis, which might be the output, might output something like rainfall or something like that. So yes, you can use that. And the Mosaic data sets are actually very good ways of actually managing that type of data. Next question from Michelle in Houston, saying which raster formats are considered lossy, which are lossless? Well, the actual formats, the name of the format, some of them are actually lossy and lossless. So, for example, TIFF, you can have a TIFF file and it can be either uncompressed. You can have a TIFF file which has, let's say, LZW compression, which is actually a lossless compression. It's suitable for data such as elevations or data that has large holes in it or no data values. A lossless would be TIFF with JPEG compression. That would be an example of a lossy compression. There are other formats, things like JPEG 2000 also have lossy and lossless versions of it. And there are other formats such as Mr. Sid, for example, is a lossy format. So different formats, and some of them are lossy and some of them are lossless. Next question from Ruth Ann in Merced, saying, are all raster tools available at all license levels? There are actually a couple of questions related to licensing levels, so I'll try and answer them in one go. So what you have seen, the tools for raster data management are available at all levels. The image analysis window that came up, that's also available at all levels. The creation or editing of a Mosaic data set is available at editor and info levels, but the use of a Mosaic data set, in other words, being able to directly access it and view it, that's available at all levels. I'll come up to concerning serving the data. There's a slight difference in the licensing there. We'll come back to that a bit later. The next one from Alan and Boyce, saying, in previous releases, pyramids on integer grids could be much larger than the grid itself. Is this still the case? Well, a lot of improvements have been made in how we handle pyramids. One of the improvements is to change from using RRD files as default to using pyramid files. One of the advantages of these pyramid files is that they enable us to use compression within the overviews, and that was a problem with the original RRD data sets. So there's pyramid files. When you actually create the pyramids, you can define compression. Even if the original data is uncompressed, it sometimes is advantageous to compress the overviews, as they're only going to be used at small scales, and that can substantially reduce the size, the file size further. Another question from Stephanie in Carlson City, talking about does the image analysis tool come standard with ArcGIS Desktop? I just answered that, so yes, it does. So those tools are there. Let's have a look at another one. Another one from Richard in Milford saying, will I be able to convert my existing services into raster mosaics? So this is referring to the use of the image server technology that was available in 9.2 and 9.3. That technology has been integrated into ArcGIS. The Mosaic Dataset is the replacement really for the Mosaic for the image services. And yes, any existing image service definition can be very easily just loaded into a Mosaic Dataset. So it's directly converted. There are no problems there at all. So you can carry on using those and serving those instead of using what was called the image server before. It's actually using the image extension to ArcGIS Server, and that's done through serving Mosaic Datasets. So that's all we have time for at this point. We'll come back to some questions after the next demonstration. Over to you, Melanie.
Thanks, Peter. Next, we're going to talk about the dynamic mosaicing and the on-the-fly processing. Most of us deal with a lot of imagery that overlaps. This is just often what we have. And the Mosaic Dataset has many options that can impact the ordering of that imagery to create this dynamically mosaic image. As we discussed earlier, each raster can be clipped by the footprint as it is mosaiced. Also, users can refine the image that they view by being able to define queries based on the values in the attribute table. And there's also a set of mosaic rules used for the dynamic mosaicing. These help define the order that the imagery in the mosaic to ensure that the best image is displayed on top. When you set up a Mosaic dataset, you can define the default mosaic rules, but the user also has control over these rules. So when we talk about dynamic mosaicing, we're just talking about the fact that this is not a static mosaic image that you get from the Mosaic dataset. All these different things will interact and affect how your mosaic image will appear. And this gives it a lot of power. We have two main mosaic rules. The first one, the mosaic method. This defines the sorting order of the rasters and the mosaic operators. The default mosaic method is closest to center. It may not be obvious, but it's shown in this image beside us with the image that's basically in the center displayed on top. Yes. The next one is by attribute. This allows you to sort the images based on a field in the attribute table, such as a date or cloud cover. And in this example, the image with the most cloud cover is placed on top. We have about 6 other mosaic methods. The mosaic operator works in conjunction with the mosaic method by allowing you to define how to resolve the overlapping pixels, such as choosing a blending operation. On-the-fly processing, which you basically saw that we can do with raster layer, is also extended to a mosaic dataset, so that the imagery in a mosaic dataset is only processed as it's accessed. By being able to process on the fly, you're able to create multiple products without duplicating any of your source data or generating interim products. There's many ways to process the imagery. This includes applying image enhancements, defining different band combinations and pan sharpening, orthorectifying your imagery, and even doing color corrections. And color corrections are actually new at 10. You can also apply shaded relief or hillshade on a digital elevation model. You define the processing using functions. These functions can be applied on each raster dataset or on the whole mosaic dataset. Mosaic datasets provide significant value by enabling you to change the way that the imagery is managed, by reducing processing time, by reducing storage redundancy, by maintaining overlapping imagery and its metadata, by allowing you to store multiple resolutions of data together, by managing your imagery in one dataset, even when your images may not overlap or join together, by maintaining the quality of the image pixels. Also, updating is straightforward. Just add new data. You can do this by either replacing the original source images or by adding additional imagery. The new images can overlap, or they can extend beyond the boundary of the original Mosaic dataset. And finally, metadata can be maintained for each image and for the entire Mosaic dataset. So now I'm going to move into my next demo, where I'm going to I have a Mosaic dataset that has multiband imagery, and I'm going to show you how to apply some functions so that we can create a Mosaic image that we want our users to see. So I'm going to shrink my data frame here a little bit. Actually, I'm going to close that data frame, open my catalog. So here I have a Mosaic dataset called multibands. I'm just going to add it to my display. I need to move a few things around so we can see everything that's going to happen. But this is actually created from that same Landsat satellite scene with 6 bands that I showed you earlier. And you can see here there's 6 bands. And instead of that black background border, I've modified the footprint. You can see these green lines to get rid of that because I'm not interested in having that information. So the next thing I want to do is edit my properties. I access them from the catalog window. And I'm going to go to the Functions tab and insert a couple of functions. So the first one I'm going to insert is an extract bands function. And just by specifying a space-delimited list, I can define which bands that I want to combine and how I want to combine them. If I click apply, you'll see that my image changed from that dark image to now what's a red image, because I'm going to create a color infrared product from here. The next thing I want to do is apply a stretch function, because that's a really dark image and it's not very appealing. So I'm going to use a percent clip, which is actually a new stretch type that we've added at 10. And I'm going to just define a minimum percentage clip here of 1.5. And click OK and click apply, and you can see that it lightened up. So the next thing I want to show you is the defaults tab. This is where I can go in and modify some of my mosaicing methods and some of the other things that impact this Mosaic dataset. So I have a list of Mosaic methods. It adds them all by default. But I don't need seam line because I don't have a seam line, and I probably don't need a viewpoint because I only have one image in my Mosaic dataset. I can also set the default Mosaic method. I'm going to keep closest to center. The other thing that I can do is, we saw an attribute table before. Here's all the fields in the attribute table of this Mosaic dataset. And I can actually turn some of these off so that if I were to provide this Mosaic dataset to somebody else, they wouldn't see those fields, which is fine by me because some of them aren't important to the user anyways. And there's a number of other properties that we can set in here. I'm just going to close that. And I'm just going to go back to my table of contents and show you that I now only have 3 bands. I have permanently changed how this Mosaic dataset will be visible by users. They can still change the band combination. They can make it a 3-2-1 instead of a 1-2-3. But they don't have access now to all 6 bands. They can also, you'll see that the Mosaic methods have changed too. I took out seam line and I took out viewpoint. So now my user doesn't have the choice of choosing those Mosaic methods. So this was just a quick demo to show you how we can add functions and change the Mosaic methods for our users. So I'm going to go back to Peter, and he's going to take some more of your questions.
Okay, thank you, Melanie. Lots of questions coming in. I'll try to get to as many as I can. First one from Stephen Ibensberg saying, if you create a raster data set, you can define a projection. Or can you provide define a projection different from the original? Does it reproject on the fly? So yes, the projections are handled extensively. Essentially, every raster has its associated spatial projection information. When you create a Mosaic data set, you actually define the projection to manage that Mosaic data set in. That's only actually used for defining the footprints, and also when you create those overviews, they will be created in that particular data set. When an application accesses the Mosaic data set, and the data is actually always reprojected on the fly from the original source directly to what the user's requirement. So that's handled very, very well. Another one from Yov in Tampa saying, when a mosaic is created, can it be used for analytics, i.e. add, subtract two mosaics using spatial analyst, for example, so that the mosaic methods are honored? Yes, you can. So a mosaic data set can be directly used as a raster data set in all analysis applications. So you basically add a mosaic data set, you define the current rules as how you want to see that, for example, using a layer, and then you can directly use that in any type of analysis. So it's very well supported. Next one from David saying, is the Mosaic dataset image data actually stored in the geodatabase or just related? So what's stored in the geodatabase are actually just links to the original data, as well as ingesting the metadata and processing information. So the pixels actually stay in their original form. That original form might be in a geodatabase if you want. Also, when you create the overviews, those are relatively small, and you have the option to either store those as files or within the geodatabase. Next, Bill from Eugene asks, can the footprint be used to reduce the visible portion of a non-orthorectified image to display just the sweet spot of the image and not the more distorted edges? Certainly. The footprint is a feature class that can be either manually edited, and there are also various automated ways of determining what that footprint is. And yes, it can be used to exclude any area of the image. So it can be used, for example, to exclude the legend from scan maps or the edges of imagery, whether it's auto-rectified or not. Next question, saying from Michael in Houston, saying, I assume the Mosaic dataset is duplicate data. The original imagery is not affected. So the Mosaic dataset, as I said, is just a reference to the original data. There is actually no duplicate data. The only thing that's really duplicated is the metadata that might have been stored originally, and that is actually brought in as part of the Mosaic dataset. There was another question about metadata from Fort Worth asking, metadata, if for each image there is a text or XML metadata, can this be served to users? So yes, when you add the data, the metadata is ingested to the system. It's actually stored within the Mosaic dataset and becomes accessible to any user who accesses the Mosaic dataset. Additionally, these attributes that you define in the table are also accessible to the end user as well. So that allows that. That's probably all we have for this set of questions. I'm hoping we have a little bit longer for the last set of questions coming up. So please do submit the questions that you have. Over to you, Melanie.
Thanks, Peter. Next, we're going to dig a bit deeper into these Mosaic datasets and how to handle more complex imagery. So when you add imagery to a Mosaic dataset, you actually use what's called a raster type. A raster type is designed to understand the file format and the specific information about a product. Essentially, it simplifies the processing of adding complex image data to a Mosaic dataset. In ArcGIS, we've got several different raster types. Some are for specific image products, and others are for specific image sensors, such as Landsat 7, Worldview 2, and Iconos. The raster type identifies metadata, such as georeferencing, acquisition date, and sensor type, along with a raster format. By adding raster data according to its raster type, the appropriate metadata is read and used to define any of the processing that needs to be applied. So, for example, when you get a QuickBird standard scene, the scene is often defined by a .imd file, and this file contains the metadata information about the raster dataset and may point to one or more TIFF files. To add this data correctly, you'll use the QuickBird raster type because it searches for this combination of file types. If you add this data as a regular raster dataset, say as a TIFF file, then only the TIFF files are recognized and added, and any metadata information that would affect the functions needed or the georeferencing would be missing. Raster types help with automation because they define how that imagery should be set up within the Mosaic dataset. And additionally, you can create your own. One of the advantages of a Mosaic dataset is it can be updated at any time. One way to update a Mosaic dataset is to add new data, which we've seen. You can do this by using the Add Rasters to Mosaic Dataset tool. You can also use a tool called the Synchronize Mosaic Dataset tool. This tool will crawl the original locations of your source files and add any new files. It will also add the imagery using the original properties defined as part of that raster type that you used to add those original source image files. This tool will also update the footprints or the metadata if they've been modified, and it will update or add any overviews that are necessary. If a user has access to your Mosaic dataset, it is possible for them to modify it. So it's not really something that you always want to allow. Therefore, you can provide access indirectly by creating a referenced Mosaic dataset. A referenced Mosaic dataset is also useful for creating additional products from the Mosaic dataset. The graphic on this slide shows one of the many ways that you can manage or configure your Mosaic dataset. In this graphic, there is a master Mosaic dataset, which is in the center. And from that, you can create a referenced Mosaic dataset that redefines the processing or defines queries to create specific products. So for example here, you can create a normalized difference vegetation index Mosaic dataset product. You can also create one where the boundary's been modified to display only the imagery contained within your county. Also, you can have another one that's a more complex thing that defines a query, maybe based on a specific sensor type, where the images have little cloud cover and only intersect with Spain. Basically, the reference Mosaic dataset is one way to create a derived product from the original Mosaic dataset. Now I'm going to go on to another demo. In this one, I have a Mosaic dataset where I've added an icono scene, and I want to update that. So my Mosaic dataset is called Portland Demo. I'm just going to drag and drop this in here so you can see it. So I have one image scene in here. So I can go back to my Mosaic dataset and right-click on it and go to Add Rasters. So here, this was something we didn't touch the first time that we were using this tool. We have a list of raster types in here. Now, if I wanted to just add all ArcGIS supported raster formats, like TIFF files and Mr. SIDS and NITF, I can read them generically using the raster dataset. But what I want to do more specifically is add something for a specific raster type, in this case, iconos. I'm going to go and I'm going to point to a folder that I have where I happen to have my 3 scenes of iconos imagery. One of them has already been added to this Mosaic dataset. And I want to do a couple of other things specific to this demo. I'm not creating overviews, so I want to make sure that the pyramids are read in a specific way. I also, because my folder has already got my source image, I don't want to re-add that image, so I'm just going to exclude duplicates so it doesn't get added accidentally. And I'm going to click OK, and this should be pretty quick. It's only 2 scenes. It's got to basically read and create the footprints for them. And you can see the processing is happening in the background. So my Mosaic dataset has been updated. and you can see my images. One thing I want to show you is the footprint. We're going to open up this footprint table because it's different than the other ones that we've looked at. There's a lot more fields in here. We have our object ID, we have the raster field, but we also have this other one. And what you might notice is it looks like there's more than 3 images in here, but there isn't. In fact, what happens is we basically, using the functions and how we define the processing, we sort of added in here twice. So because our Iconos has 4 multispectral scenes that are at a lower resolution than our one pan scene, we don't necessarily want to pan sharpen the whole image even when we've zoomed out to a really low resolution. So we have one grouping in here, our multispectral, defined by this tag, that represents our pixels at the lower resolution. And then we have our pan sharpened combination here that pan sharpens at the right scales using the pixel resolutions that make sense there. There's other things in this table. We've got the product name, GeoOrthoKit, that might be what you had requested when you ordered it. The sensor name, Iconos 2, which is the satellite sensor that it comes from, information like the acquisition date, and other metadata that was collected, such as the sun elevation and azimuth and cloud cover. So one thing I also want to show you is we can go in and look at the functions applied to each raster. I just want to reiterate that you didn't see me add functions, and I didn't add functions. These were added as part of the raster type. So there's a set of functions here that get used to combine just the input bands, the blue, the green, the red, the near infrared. There's also a set of functions that get applied to the pan band. And then finally, these 2 inputs get pan sharpened together to create your output. And it's that simple. My Mosaic Dataset is now ready for people to use. So next I want to talk about how do you make your imagery accessible to your users. The first way is through the direct access, and I've been using this so far in each of the demos. Direct access refers to working with and accessing your data files directly. This includes raster datasets. It can also include your Mosaic datasets. The other main way to access your imagery is through a server. ArcGIS Server allows you to make imagery available over the web as image services. There are a multitude of ways to connect as a client to these image services. You can connect using ArcGIS Desktop or Explorer. You can build web mapping applications using environments such as Silverlight and Flex, and these make connections to the image service using Raster SOAP. You can connect with standards such as Web Mapping Service or the Web Coverage Service using third-party applications. Creating an image service is really very straightforward. There's 2 main sources for an image service: a raster dataset, either directly or using a layer, and the Mosaic dataset. And at any time you do serve a Mosaic dataset, you do require the image extension for ArcGIS Server, which Peter mentioned earlier. One thing that makes an image service very powerful is that you can use it like you're accessing the source raster or Mosaic dataset directly. You can use it as an image for visual analysis or as a base map. You can access the pixel values, so it can be used as the source in any image analysis or just perform and identify on the pixels. And if you're serving the Mosaic dataset, you have access to the attribute table, so you can perform queries and even download the source images. Another way to make your imagery available is to add it to a map document and cache it. A map cache creates tiles at various scales, and these are optimized for web delivery. You can create and serve the map cache using ArcGIS Server. And one example of a cached map service is the many services available in ArcGIS Online. So I'm going to move to my final demo now, where I'm going to show you how we can basically serve up some of these things that we've created. So I'm in my catalog window, and I have a servers connection. There's also a server manager on the web that you can access. And I have an admin connection to my image server. First thing I'm going to go do is find that layer file. I'm going to just drag and drop. This is one way that you can publish an image service. An image will automatically turn into an image service. The other way is to basically right-click on it. Where did I put it? Well, we'll use this one. I can right-click on my image service and publish it to ArcGIS Server. I can change the name of the service if I want to. I can also check on some of these capabilities like WCS or WMS. And when this is done publishing, it appears here, just like the layer one did. So now what I want to do is just add these to ArcMap so you can see them. So the first one is my layer file that I created. And this is just my raster data set, which was originally a Landsat. It originally had 6 bands. Now it only has 3. And it's been clipped. And basically, it's being processed on the fly to give me this output. The next one is my Iconos. And I just want to show you, I'm going to pin this open, that it appears here as a single image, even though we know it comes from a Mosaic Dataset. We do have access to see the footprints if we want. I can go and open the properties. And I can change the display to show my footprints. These show up as red lines. I don't have to have those open, of course, to access the catalog. I can also open the attribute table for this. And this gives me basically the same attribute table that we saw earlier. I still have access to my imagery. I can go and I can preview each of the individual images. If I had metadata, which I don't, I could show you the metadata for that single image. The other thing that I can do is I can make a selection. I can use the selection environment, or I can just use the selection tools, or I can use the table to select something. And I can download my data. So not only do I get each individual TIFF file, I should also see my .imd file in here, but I have my XMLs, my RPC file, everything that came with my original source image. So I can now work with it independently if that's what I choose to do. So this is the end of my demo. I'm just going to go back to Peter now, and he's going to answer any of your remaining questions.
Okay, thanks a lot, Melanie. First, a question from Jeff in Phoenix saying, we get about 10 terabytes of processed imagery each year. Is the Mosaic Dataset suitable? And the answer is certainly. Mosaic Dataset is the recommended method of accessing and serving all forms of imagery. What you'll be able to do is just create a Mosaic Dataset that directly points to the data, and very quickly make that accessible, both the old data and the new data, publish that, make that accessible to your users, and then each year you can literally just add the new imagery to the old one, and users will be able to have access to both the old and the new imagery. Next question from Randall in St. John's saying, can geoprocessing create a raster data set and automatically add it to a mosaic, i.e. without having to recrawl the file locations and manually add it? Well, one of the things we've done at version 10 is to enable the modeling environment and geoprocessing tools to be able to work very well with Mosaic datasets. And this enables you to create various types of scripts and geoprocessing models which can actually do that. So yes, that can be automated. Next question is Chris from Vancouver asking, are the tools to provide atmospheric corrected satellite imagery, for instance, converting Landsat to top of atmosphere? So we don't actually provide directly the functions to let's say, do that conversion, but those functions can easily be added. They're essentially defining stretches based on the meta information, and that can be relatively easily automated. There are various ways of doing that, but we don't actually provide the tools to automatically add those specific functions, but they could be added. Another question. From Kevin in Houston, which language is used to write processing scripts? To actually automate things, we can use the geoprocessing tools, and those can be, for example, written in Python. Additionally, users that want to add new functions can actually, there are methods of actually writing new functions to be used, but and that's much more low level. Next question from Joe in Leewood saying, would the image extension for ArcGIS Server be required to serve out Mosaic datasets via web service? The answer is yes. To actually serve a Mosaic dataset out as a web service, you actually need the image extension. Another one, Jin from Wellington asked, can Mosaic dataset imaging be viewed in Google Earth? The answer is yes. Whenever you publish an image service, we automatically include the REST and SOAP interfaces to access that imagery, and those actually also provide KML, and therefore if you actually go to the services directory, you will see a link to the KMZ file, and that can be used. Alternatively, you can access imagery using the WMS and WCS. Next question was, I'm just trying to find them all here. Mosaic Dataset versus Image Server, they seem very familiar. Yes, they are. I mentioned that before, is that the Image Server technology has really been integrated. Mosaic Dataset is the new method of managing the different types of raster. The Image Server, even at 9.3, actually became an extension to ArcGIS Server. That's the same. In that extension is required to serve the Mosaic datasets, although no extension is required to directly serve a raster dataset or a layer containing a raster dataset. Next one, S from Fort Worth asked, does all the footprint recalculate methods included in ArcGIS Image Server under the radiometric calculations exist in version 10? So this refers to tools that were available within the image service definition editor previously on how to automatically determine the footprints of imagery. And yes, those tools have actually been improved. So there are new ways and better methods to determine those extents. Let's have a look at another one. Santosh from Lake Grove asks, what's the difference between pyramid and overview? Just to clarify that again, a pyramid is really a reduced resolution data set created for an individual raster, whilst an overview is the term that we use to define essentially the same thing created for a complete Mosaic data set. It really is, if you zoom all the way out to the world and you have a Mosaic data set which contains maybe millions of images, we don't want to open each one of those at the very small scales. We display the imagery from the pre-generated overviews, and as you zoom in, when a suitable scale is reached, then it starts using the original data. So those overviews are actually very small. Next question. Let's refresh this so that the new ones come in. What's the migration path? This is from Richard in Redland saying, what's the migration path from image server to the Mosaic dataset? Well, it's very easy to just import an imageless definition, which might have been created in the old technology, directly into the Mosaic dataset. A question from Fort Worth. When users download data, is there a limit in size and pixel size? So when you publish an image service and make it accessible an end user can connect to it, view the imagery, and then they can actually do an export. And what the export does is enable you to define an extent. It could be the extent of your screen, it could be a graphic, and then export that data in a user-specified projection and pixel size. Now, when you actually publish that Mosaic dataset, you can control limits on what size that a user is allowed to actually download. In a similar way, you can actually control the pixel size by just reducing that as parameters in the Mosaic dataset. The other way to do that is to actually go download, and this is also a new capability for users that actually want the original pixels. The download capability enables the user to make a selection set from a service, refine that to specific rasters, and then actually download the original pixels with the metadata. Additionally, there is a clip option in that so that a user can define a graphic, and the system will actually extract the original pixels, download those in as a new file, and also update the metadata associated. So it's a very powerful way of being able to access the original imagery if required. And yes, they can limit it, sorry. What else? I think we have quite, time for one more question. There's a question here from Olivia in Dallas saying the image tiles are automatically seamed up. Can accurate contours be generated? So yes, we use Mosaic datasets extensively for elevation data. The elevation data can be in different projections, different pixel sizes, different formats, and when you serve it and make it accessible, they become accessible either as elevation data sets that can be directly used in various processing tools, including the creating contours. So what you do is when you define that processing tool, you actually define the pixel size at which the processing will be performed, and the server will return the appropriate pixels correctly reprojected, and you can use that for various types of processing. So the answer is yes to that. So I think we've run out of time. Thank you very much. I will pass you back to Melanie.
Thanks, Peter. Before we go, I just want to point out a few resources to you. We have an instructor-led training that's coming up in the fall of 2010. This will go into much more detail about how to manage imagery using ArcGIS than this seminar was able to provide. We also have a resource center for imagery management. This provides you direct access to the help system files that you'd be most interested in, access to the forums that we have. We also have a new blog, which was just started this week. So we, from development, will be able to present information to you that in a less formal way than some of other systems, and you'll be able to comment back to us. And then additionally, we have tutorials. So if anybody's interested in learning about how to create these Mosaic data sets and add data to them and how to work with the different functions, we have tutorials and workflows in our Raster management section of the help system to help you get through this. And you can access that right now through the web help. So before I go, I just want to say that your comments help us improve our seminars. So please take a moment to complete our survey. Just click the Give Us Feedback link to take the survey. And we hope that you enjoyed today's seminar. On behalf of ESRI, I'd like to thank you all for attending.